Hey kids, welcome back to some more science. Science is cool. We are going to be moving on to our unit about outer space. Yes, one of my favorite units. Outer space, planets and stars. It's so cool. But before we get to all that, we have to learn about a few concepts that are going to be super important on our journey into space. So, let's get started. Today we're going to talk about pressure and vacuum. And these two scientific concepts are opposites each other. But to understand them, we have to start at the beginning with atoms. Now, I'm not talking about that guy sitting next to you named Adam. I'm talking about the building blocks of everything. We can't see them. They're really, really small. You have to have a very special, powerful microscope to see atoms. But we know they're there because we've seen them. Now, I don't have one of those special microscopes, so I'm going to use some Legos to talk about atoms and about why they're important. These Legos are like atoms. I've got a whole jar full of them here. They're different sizes, different shapes, and I can build them together to make something, right? I can make trees or houses or cool cars. Yeah? All right, those are my atoms. Another topic I want to discuss is solid, liquid, or gas. No, not that kind of gas. No, not that kind either. No. Gas like air. Air is a gas. Helium is a gas. Those things are gases. What is a gas? Well, let's figure out what isn't a gas. First, let's talk about solids. I have some solids right here. This is a solid. 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 So what do these things have in common? Well, they keep their shape. They keep their shape no matter what I put them in. It's a square. Still a square. Still a square. Still a square. It doesn't change its shape. The atoms in this object are squashed so tight together and they don't move. They're like sleeping. They're not moving. They're keeping the shape. They're locked together and keeping the shape. Same with this toy. The atoms inside this one are squashed together and they're not moving. They're keeping their shape. Same here. A solid is something that keeps its shape no matter what container you put it in because the atoms are keeping their shape. That's a solid. All right? So a solid doesn't change shape no matter what container you put it in. What about a liquid? I have here a liquid in a pitcher. I've put some red coloring in so you can see it. Let's start with this container. I am going to pour in 200 milliliters of this liquid. It's on the 200. See? Okay. Now, what happens if I pour this liquid into this container? It's a different shape. Ooh, look, I have more, right? No, you saw me. I poured it from here to there. It's the same liquid, but it's not the same shape anymore, is it? Now it's taller and skinnier. Well, what happens when I pour it into this container, which is yet a different shape? Change shape again. So in this container, the liquid was kind of short and rounder down at the 200. In this container, because it's a skinnier container, it was taller. And in this container, it's kind of in between. So that's a liquid. A liquid takes the shape of the container that it's in. What happens if I pour this all over the table? Yeah, you probably can figure out it's going to go everywhere, right? That's the other property of a liquid. A liquid cannot hold its own shape. It'll go all over the place. So a liquid needs to be in a container. So we learned about solids. Solids are keeping their shape no matter what container they're in. We learned about liquids. Liquids need to be in a container and they'll take the shape of the container they're in. Our third phase is a gas. This is a gas. This is a jar full of air. Tricked ya. It's air. We got air everywhere, don't we? So air is a gas. But air is made up of lots of different kinds of atoms. There's no such thing as an air atom. Air is made up of oxygen, that's an atom. It's made up of nitrogen and hydrogen and helium and lots of other things. Those are all atoms, and together on our planet, that's our air. Now, the gravity on our planet pulls that air down towards the surface a little bit. The air piles on top of each other like a blanket, low down. Lots of air to breathe here. Now, if you were to climb a tall mountain, you would find it's a lot harder to breathe. Like if you go to a really tall mountain, the air is what we call thinner. There's not as much little atoms there bouncing around. More of them are towards the bottom, below, at the bottom of the mountain. As you get higher and higher and higher, there's less and less atoms bouncing around until finally you get to outer space. And in outer space, there are no air atoms. There's nothing. There's no oxygen out there. That's the vacuum. Down at Earth level, on the ground, we have our atmospheric pressure. And that's all of that air above us piling down on us. And it's good for our bodies. It keeps our skin healthy, get everything in. We can breathe. When we go up into outer space in the vacuum, not so good. And we're going to talk about why that is, because scientists needed to understand this before they could send people into space. For the next part of our lesson, we are going to make a gas by mixing two things and causing a chemical reaction. I have here some very, very stinky vinegar. Ugh. And I have some baking powder. By themselves, nothing happens. They are both, well, no, they're not both solids. This is a solid and this is a liquid. We're going to make a gas. And this is how we're going to do it. Safety first. I am going to take some of this vinegar and pour it into my beaker. And I'm going to take some of this baking powder and plop it into. And look what happens. It's bubbling. These two items, when you put them together, react and create bubbles. But what you can't see is these bubbles release gas. Now you can't see that because the top is open and all the little gas is coming out into the room. It's a little stinky. Maybe that's what I'm smelling. But what if we could do something with that? What if we could use that gas to do some work for us? Let's try it. Okay, so for this part, rather than letting those air bubbles go out into the room, we're going to capture them in this balloon. Stretchy. And this is going to demonstrate pressure. When the air bubbles go into the room, there's no pressure because the gas can just go everywhere. But if I contain where that gas can go, that's going to create pressure because they're going to crowd in there. So let's check it out. I'm going to repeat the experiment I just did with my baking powder. Kind of making a mess, but that's okay. Science can be messy. I'm going to add my vinegar. And then I'm going to cap it. Cap it with the balloon. And let's see what happens. It's still making the air bubbles, but now there's nowhere for those bubbles to go except into my balloon. So it is blowing up the balloon. This is an example of pressure. See, do you remember how the balloon was flat? Now when the gas goes up in there, the gas is pushing out on that balloon and the balloon skin is pushing back and creating pressure. It's hard, see? I didn't blow that up. The air bubble's dead. Pressure. So a little bit more on pressure. Pressure happens when something is compressed. It's squished, and it's a property only of gases. So if I have my solids here, I can press on them, I could stick a car on them, and they'd probably break, but they don't compress. They might get smaller, but only because the pieces have squashed. It's not quite the same thing. Liquids, here's my liquid. I've got a syringe to suck up some liquid. I have a rubber surface here so I don't hurt my hand. That's how much liquid I have. If I try to press down on the syringe to squeeze that liquid smaller, I can't. I can't do it. Liquids do not compress. But gases, I'm going to suck up a room full of air now. There, my syringe is full of air. Gases can compress. Notice, I just pushed the plunger about halfway down. The air inside of that syringe is squashed. It's got more pressure than it had before because it's in less space. Imagine if you and your friends all got squashed into a smaller room. You'd be bumping into each other. You'd be pushing on each other. You would have more pressure too. Another example of pressure, one you're very much aware of. I have a balloon and I have an air pump. And I can blow it up with my mouth, but then I can't talk at the same time. So I'm going to have the pump do the blowing up for me. Let's make sure that's on there. All right. Right now, there is no pressure in this balloon. There's hardly any air in there, but there's a lot of space. Little bit of gas, big space, low pressure. But what if I put more gas into that same small space? Let's take a look. Growing, 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 growing. Wow, my balloon has gotten bigger. I have squashed more air into the space. Now, this air, this balloon can stretch, so it did. The pressure probably isn't too high. Eventually, though, it would pop. There'd be so much pressure on the balloon that it couldn't stretch anymore, and it would pop. But there's an example of pressure. When you take a gas, like air, and push it into a container and keep pushing, the pressure gets higher and higher and higher. Only gases can be compressed inside of a space. Liquids and solids cannot. So we learned that by causing pressure, putting those gas bubbles into a balloon, we can cause the balloon to blow up, right? Get bigger. And that works because the balloon's skin is stretchy. What happens if we put that same vinegar and baking powder into something that isn't stretchy? And there's nowhere for that gas to go, and it just gets all squished and squished and squished and squished and squished. What happens? Let's find out. Safety first. All right, so I have here a canister that's got a tight-fitting lid on it. This is going to be my safety science place because this is going to be messy. All right, I'm going to start with the baking powder. Put some of that into my little container. Gotta get ready. I'm going to pour that in there. I'm going to quick put the lid on. Put it all in there. Uh-oh. Oh, did you see that? Let's watch it in slow-mo. So because the pressure couldn't get out, it blew that lid off. What can we do with that idea? We can make a rocket. Let's do it. Okay, we're gonna try that again, but this time with a rocket. Yes. I've taped in the container. See? The container's in there and it's taped to the rocket. All right, here we go. Same idea. We're going to take and put a little bit of the baking powder into the container. All right, ta-da. Next, going to get ready. Pour that in. We're going to cap it off. Get ready. Uh-oh. What's going to happen? Oh, did you see that? It hit my ceiling all the way up. Woohoo! Let's watch that again in slow motion. It's so cool. So now you should understand the idea of pressure. Pressure is when you take a gas and you compress it, you squish it into a fixed container. And so because those molecules, those atoms are all squashed together, the pressure goes up. They're mashed together, they're pushing, they're not happy, it goes up. But what happens when you do the exact opposite? That's a vacuum. If you were to take all of the atoms out of a container, no molecules, no atom, the absence, that's a vacuum. That's what it looks like in outer space, a vacuum. So we're going to learn about a vacuum and do a couple experiments with vacuums. I have here a machine that's a vacuum machine. It's used for sealing containers like this one to keep food fresh longer. But for our case, we're going to help it make us a little bit of outer space. Up in outer space, there's no air. It's a vacuum. So what happens if people went into outer space without a spacesuit? Well, we can do a demonstration of that using this balloon. I'm going to blow the balloon up just a little bit. And I'm going to tie it off so the air can't get out. And my little face. My little astronaut. Hello, I'm a little astronaut. Very happy. Not sure he's going to be happy in a minute. But we're going to put him inside our container. Okay? You see his little face? Alrighty. Here he is. Let's back this up so you can see it. Alright. I'm going to put the lid on and lock it down. Right now, my astronaut's inside, but there's also air inside. So it's kind of like if he's standing in a room. I've got air on me, no worries. But what happens if I take the air out? Of course he can't breathe, that's a different problem. But our bodies are used to having all this air keeping everything in together. What happens if that air's not there? Here we go. Safety first. It's a little noisy. What's happening with our astronaut's head? It's growing. Our astronaut's head has gotten bigger because now, with less air, no air, pushing down on his skin, all of the air inside of his body is kind of pushing out more. And the best way to really see this is once I put the air back in. When I turn this knob on the top, it's going to let the air back in. Watch what happens to our astronaut. He shrinks back down. So, no, his body didn't get so big it popped, but clearly I think it would have been pretty uncomfortable. Scientists learned that people have to wear spacesuits in space when there's a vacuum, anytime there's a vacuum, because our bodies are meant to be in a place that has air pressure. And in a vacuum like space, there is no air pressure. Here's another experiment about why vacuums matter to astronauts. Do you remember that vacuums mean no air? Well, I have a candle here. Candles, like people, need air to work, right? We have to breathe. Turns out fire has to breathe. Without air, fire goes out. Without air, people go out too. So, if I take this candle, which is eating and gobbling the air around it, and I cover it with a jar, okay? What's gonna happen is that candle, the fire is gonna use up all of the air in the jar. Kind of like if you put me inside of a jar too and cover the lid, I breathe up all the air till there's none left. When that happens, not so good for me. Guess what happens to the candle? I've covered the candle. It's using up the air in the jar. And what's happening? It's going to get lower and lower and lower until it can't burn any more. I didn't blow the candle out. Didn't run out of wax. There's no wind in here. The candle went out because there's no more air in the vacuum that it created. The candle used up all the air and made a vacuum in there. We can't go into space without bringing air with us. because just like the candle, we need air to stay alive.
Art project time!
Now, I bet you wish you had a cool rocket like I did. Well, unfortunately, those little film canisters that I used to put on the bottom of the rocket, I can't find those anymore. But I have another idea for a rocket that you can make using pressure. It's called a straw rocket, like this. You're going to make a little tiny rocket out of paper, and you're going to launch it with a straw using the pressure from your mouth. Because when we put the little straw rocket on top, there's no opening at the end. The pressure builds up beside it when I blow on it, and off it goes. So get ready to make your own straw rocket.
Here's a template for the straw rockets. Take a screenshot and print it out. Or each rocket has a body 2 inches by 4 inches and then a 1-inch square cut on the diagonal for 2 fins.
Here are the items you're going to need to make your straw rocket. You're going to need the template that gives you the sizes of the rockets and the fins. This template actually makes 4 rockets, 1, 2, 3, 4. Or a grown-up may have already cut these pieces out for you. To make each rocket, you will need 1 rectangle and 2 triangles. Then you're going to need a pencil to roll your rocket around. You're going to need some crayons to decorate, or pencils. Don't use markers. The markers make the paper too wet, and then the tape doesn't stick. You're also going to need some tape. Clear tape is best, but you can use masking tape too. And then you're going to need a bendy straw. You can use a regular straw, but the bendy straws are awesome. Do make sure to put your name on it, either with tape or some other way, because if you're in a room full of friends, you're going to all get mixed up with your straws, and that's just yucky. So make sure you label your straw. You're going to want to label your rocket too, unless you have a really unique design. All right, let's get started. Okay, the first thing you're going to want to do is decorate your rocket. Make it look unique. Not only is this fun, it also makes sure that if your rocket gets lost in a room with your friends' rockets, you'll know which one's yours, because these things are going to be flying all over the place. Now, I've already decorated one rectangle, like this. I put on the words NASA and I made a rainbow, but you can do whatever you want. The next item is to turn it over on the non-decorated side and take your pencil or thin marker, and we're going to roll it. Now, I do want that NASA to be showing, so I better go this way. Roll. Don't make it too tight. The straw's got to fit in there. You're going to roll it up the long way. And then you're going to take a piece of tape, tape those edges shut so that it doesn't come unrolled, and pull it off the pencil. You're done with that. The next thing you're going to do is you're going to need to close off the top of the rocket. Now, since my words go like that, the top of my rocket is here. It's really important that this top part is airtight, otherwise your rocket won't go. The best way to do this is to pinch the top flat and then just sort of mash it over into a triangle. The triangle just makes it look cool. Honestly, these rockets don't need to have a lot of great wind resistance, so just make it look cool. And then I always take the tape and go right over the top and then wrap it around. If you've got tape sticking out, you can fold it down and add another piece, or you can snip it. But there has got to be no hole on the top there. You can try putting your mouth in this one and blowing. If you hear air coming out the end, then you've still got a hole and it won't work. I'm going to assume mine's okay. The next step is to add our fins. These are going to help the rocket go straight or crooked or swirly or whatnot. I've taken a piece of tape, this is a little tricky, and I'm going to rip it the long way so that I have 2 pieces. I'm going to lay it down just right across my triangle, like that. And then I'm going to put that on my rocket. Now, don't stick it over the end. You don't want to block that hole, like that. I've moved it up away from the end a little bit so the tape doesn't flop over the end of the hole. And now I'm going to flip it over on exactly the opposite side and do the exact same thing. Okay? And then to make my rocket look cool, I'm going to stick my thumb on that part so the tape doesn't come up. And I'm going to bend those. Okay? If they're falling off, you can add a little more tape. But that's what your rocket should look like. All right? Now we're ready to launch them. Woohoo! Now that you've made your own straw rocket, here are some rules for launching it. First of all, make sure you launch it at a wall or into a space with nothing in it. These little rockets get lost really easily if you shoot them towards a bookshelf or where the toys are. So it's best to aim them at a wall, even if it's a pretty far wall. If you can go out into a hallway, that's even better. Rule number 1, the most important rule is you all don't have safety glasses. So don't aim these rockets at anybody's eyes. A rocket in the eye does not feel good. Aim it away from people. Also, if you want your rocket to go far, you need to tilt your straw like this. Oh, I forgot to tell you too, the little end goes in your mouth, not the big end. The little end. You want as much pressure to get through there as it can. You want to give that straw lots of room for that air to go super fast to knock your rocket off, okay? So you're going to put your rocket on the end of the long side and put the short side in your mouth. Now, if I blow it like this, it's going to go straight up. And of course, something I might do is go look at it. I'm probably going to get a rocket in my own eye. So don't shoot it straight up. Shoot it out. If I shoot it like this, it's going to go plop. So if you want to go far, you want to be kind of right in between, right about there. In order for your rocket to go super far, you need to give it a burst of pressure like that, not a. If you blow just a tiny bit, your rocket might not even make it off the launch pad. When you put this in your mouth, a big strong burst like you're blowing out a birthday candle. And it goes without saying, don't jam the rocket onto the straw. Make sure it can rest freely on there, just lightly on there. If you find your rocket's not going, 2 problems might be. 1, there's a hole at the end and the air's escaping. Or 2, you've jammed it too hard on your straw. So try fixing both of those and see what happens. All right, have fun with your straw rockets, because rockets are cool. Well, that's our lesson this week on vacuums and pressure. Have fun with your straw rockets, and remember, science is cool.